It's a remarkable thing.
How phenomenal is that?
Yeah. So we've had those two photographs. The other thing we've had is so-called gravitational wave detections. So these are colliding black holes, and they collide and merge together. And obviously that's quite a violent event in the universe. And so that event, that process ripples space-time. So it sends ripples out in the fabric of the universe, space and time. And actually Kip Thorne is I've spoken to him several times. He's one of the greats, right? Won the Nobel Prize for this. And he calls it a storm in time. So you get a time storm. So really, we're to think, as we speak now, there will be these very tiny ripples from violent cosmic events passing through this room. And they're changing the rate that time passes. So that as they go through. And we can detect that now. So we have detectors that can pick that up. And so we've seen those collisions as well.
So these collisions, how far away?
Oh, millions of light years away.
And they're affecting what's happening in this room right now?
Yeah, to a tiny extent. So there's an experiment called LIGO, which is what it stands for, something like gravitational interferometer. I can't remember exactly what but so basically it's laser beams. And there's one in Washington State, north of Seattle, and one in Louisiana. And they're kind of laser beams, 4-kilometer long laser beams at right angles. And they can detect these very tiny shifts in effectively, you could say, the length of the laser beam. It's a bit more fiddly and complicated, but it essentially measures the distortion in space-time caused by these ripples.